Hi, in this video, we're going to take a look at determining confidence intervals for population proportions. So, last couple of videos, we were looking at confidence intervals for population mean. This one, we're going to look at population proportion. So our point estimate for our confidence intervals for our population proportion is the probability of obtaining a successful outcome from our sample. So much like we talked about with sampling distributions, the mean of our sampling proportions target the population proportion. So that's what we're going to use as our point estimate as well. That probability of success from our sample. Our standard error is the square root of the probability of success times the probability of failure divided by the number in the sample, or the sample size. So our confidence interval for our population proportion is thus: our point estimate is p, probability of success, plus or minus z sub alpha over 2. So just like we talked about in our last tutorial. And then times the standard error for our population proportion. So once again, this z sub alpha over 2 times this big square root expression, that is our margin of error. So we'll take a look at that, and we'll in a couple of examples in this video. So example 3, in a recent sample of 578 voters, 301 of them favor a proposal to renovate a local park. Construct a 90% confidence interval for the population proportion of voters who favor the renovation. So you'll hear oftentimes, especially on the news, a recent study or a recent poll showed that a certain percentage favor that, and then might add a margin of error to that as well. I'd prefer if everybody did that, but unfortunately that's not the way the world works. So I'll show you how to do this by hand, and then we'll see the computer Python program in action as well. So our probability of success is 301 out of 578, which is 0.521. So that's what we're going to use as our sample proportion. We can use as our point estimate here, this 0.521. And then plus or minus 90% confidence interval has a z alpha over 2 value of 1.645. So 90% confidence interval is 1.645 standard deviations from the mean. Our standard error, 0.521 times, if there's 52.1% of the sample favors it, that means there's 47.9% of the sample that don't favor it, so 0.479, divided by our sample size, which was 578. So doing that calculation, here we have our point estimate again, 0.521, plus or minus. Our margin of error is 0.034 or 3.4%. So you might hear according to a recent study, 52.1% of voters favor renovating a local park with a margin of error of 3.4%. This is exactly what we're talking about here with margin of error, which again is influenced by such things as sample size and the confidence level here. So in this case, 90% confidence level. So adding and subtracting that 3.5 or 3.4% to our 52.1%, we get about 0.487 to 0.555. So we have a 90% confidence interval for the population proportion of voters who favor the renovation is between 48.7 to 55.5%. In terms of using Python to calculate that, and I will link this code in the description, here we have 301 successes, a sample size of 578. We're only using a 90% confidence for the level for this, though. And let's see what we get. There's our 0.487 when we round up to 3 decimal places, and our 0.555 when we round up to 3 decimal places as well. So again, we don't have to do these calculations by hand necessarily, but I did want to show you in terms of the margin of error of 3.4%. Example 4, the results of a sample of 40 students who took a pass-fail statistics exam are shown below. Construct a 98% confidence interval for the population proportion of students who pass the exam. So we're looking at students who pass the exam, and this is a sample of 40. So out of all the students that could have taken this exam, maybe it's a national exam, who knows, what would our 98% confidence interval be for the population proportion? So we do want to get a raw count of all the ones who passed, and there are 30 that passed in this group. So 30 out of 40 is 0.75. So If you're doing it by hand, you got to use 0.75 as your point estimate. Here, we can also do 30 of them passed. We had a sample size of 40, and our confidence level is 98%. So calculating this one, we get about 59% here, 59.1% to about 91%. So again, if we had to calculate these by hand, probability of success is 0.75, calculating it out. Our margin of error here this time is 0.159, or about 16%. So we got about between 59 to 91%. By the way, you can also work backwards on this, and if you know the 98, you know the endpoints of the confidence interval, to get the margin of error, just subtract these two values and divide by 2. If you want to know what the point estimate is, take the midpoint of these two values. So the midpoint of 59 and 91 is 75. So that's your point estimate. If we subtract them, we get 32. Divide 32 by 2, you get 16, which is roughly our percentage for our margin of error. And again, we do have a high margin of error here because we only have a sample of 40. So as we saw in our previous video, by increasing our sample size, it decreases our margin of error. So again, we want to get as many representative samples of the population as we can. So 40s, if we can get more, that's great. But the bigger this number, the smaller this margin of error would be. So, all right, that about does it for this video. Thank you for watching. I'll see you next time.